Okay, so we get E is equal to VB. Now, where do you use this? You'll see it in questions where it will say, like a charged particle is entering a magnetic field, and it might ask you to find the radius of the path, and then or it'll say, what would be the electric field needed to be placed across this so that the particle could go through with an undeflected path, meaning that it would go straight through. Okay, so that's when you would use it. Or it might say, what will the speed of the particle need to be as it passes through this? So an example would be a beam of electrons travel in an undeflected path in a tube where the E balances the B. The electric field balances the magnetic field. The electric field strength is 7 times 10 to the 3 newtons per coulomb. The magnetic field strength is 3.5 times 10 to the negative 2 Teslas. And the question would be, what does V need to be? What is the speed of the electrons as they travel through the tube? So you would go E is equal to VB. So V is equal to E over B. So 7 to the third, I could make this bigger, 7 to the third newtons per coulomb over 3.5 to the negative 2. I hope you appreciate the nice numbers I picked. And that goes in 2 times 10 to the fifth. And you get newtons per coulomb over Teslas. It should be meters per second. So I want you to pause this video for a second and prove to me that newtons per coulomb over Tesla is equal to a meter per second. Okay, so pause it right here and then restart it, and I'll do it with you. Pause. All right, so a newton per coulomb over a Tesla. Well, we know from F is equal to BIL sine theta that B is equal to F over IL, which means a Tesla is equal to a Newton over an amp meter. So instead of a Tesla here, we could do a Newton over an amp meter. And then dividing by a fraction is the same as flipping and multiplying. So a Newton per coulomb times an amp meter over a Newton. So the newtons will cancel, and we'll have an amp meter per coulomb. So then on the side we say, well, we know I is equal to Q over T, which means an amp is equal to a coulomb per second. So where my amp is, I could put in a coulomb per second. So a coulomb per second times a meter over a coulomb. Coulombs cancel, and we get meters per second. So this is indeed meters per second. Okay, so for homework today, I would like you to do on page, sorry, I just needed to move it so I could see. So I'll put it up here. So on page 539, numbers 1 to 4, and on page 552, numbers 1 to 3 and 5. Okay, they might take you back to make you use R to find the radius in some of them, and then the electric field, but you could handle that. Okay, so these questions for today. Have a great one. Thank you.